Hi folks, today is day 2 of the exam grading. We are not done yet, and hopefully we could be done by the end of the day or maybe tomorrow. And I want to give you a very brief update. But first of all, I wanted to say that to all students that send thank you notes via email, that I'm going to respond to them, but right now our focus is on the grading the exams and to submit the grades to the registrar's office. However, I know that you are anxious, especially because we don't have a answer key for the exam. I want to provide you some information about the exam so that we have an idea how you did. I have with me here the green version. There were 3 different versions of the exam. So what I say here is about the green one, okay? But in general, the same principle, so that you have an idea. So the question number 1 was this question about the false and the true. Most of the class did very well on this particular one because you practice many times in class. So I'm not going to go one by one. The question number 2 is this single point mutation that causes sickle cell disease. And obviously the answer for that is GLU6-Val, glutamic acid. Position number 6 mutated into valine. So if you knew the amino acid but you didn't know the position exactly, for example, if you said glue and the wrong number, val, you still get partial credit for that, okay? We look at everything, we are trying to get partial credit for everything that you do. The question number 3 is about this structure, the beta subunit of a deoxyhemoglobin. And they ask you 4 questions about that structure. And instead of putting colors, as we know that the rainbow palette that you use from the blue to the red, but we didn't use that in consideration for the possibility of having students in classes that are so-called colorblind. So we just put the asterisks and the marks there for you to identify what we would like. So the first one, name the helix label with 1 asterisk. The answer for that question would be C. That was one of the helixes, C. The question number 2, with 2 asterisks, the answer for that would be D. And with the 3 asterisks, the answer for that is A, because that is the N-terminus of that protein. Question number 4, estimated the number of amino acid residues with that helix labeled with a double dagger. That helix holds the proximal histidine. And we know that the proximal histidine is in F8. And we look at the helix, there is probably 1 or 2 more amino acid residues after that one. So we took both answers. If you said 9 amino acid residues or if you said 10, we got that as correct because there's no way to know exactly the number of amino acid residues. Number 4, it's about the peptide, and the peptide happened to be the same peptide that I used for the t-shirt here. That's thanks, and I'm assuming that most of you got that right. And the question about the PI of the peptide, in the peptide tanks, there are 2 basic amino acid residues. In particular, lysine contributes to push up the PI, so that's going to be a basic PI above 7. Ask you to draw a rectangle around 1 peptide bond. 1 peptide bond. So you have to select 1 peptide bond, incorporate the carbonyl, the NH, the amino group, and also the alpha carbon before and the alpha carbon after that. Okay, so that will be the 6 atoms that are going to be in your plate. Question number 5, explain what the HbA1c is. The answer for the question is already there because Hb is a type of hemoglobin, and the type of hemoglobin is bound to sugar, and it tells you the amount of sugar that you have in average for the last 3 months. So it's commonly referred to A1C. They don't call the name HbA1c, but I gave the whole name there so as a hint for you to know that this is a type of hemoglobin. Question number 6, The question number 6 is about enzyme kinetics. Give a Km, gives a Vmax, and the Vmax is always given in a very high concentration and a velocity at a very high concentration, which infers at the Vmax. So the Vmax in here was 150 nanomolar per minute. The version that I have here with me, the Km was 2.4 10 to the power of minus 6, negative 6 molar. The other versions are different numbers, but they're all the same thing. And this was a problem that I solved in class during the presentation about this subject line, okay? And there are questions just calculating instantaneous velocity for two different concentrations. One concentration is very low, and the other concentration in all exams is going to be equal to the concentration of the Km. So what that implies, if the concentration is equal to the concentration of Km, you are going to get half of the velocity, right? Because the Km is the concentration of the substrate that gives half of the maximum velocity. You don't need to know that, but we have to calculate that anyway, and we are going to see, you could check if your answer was correct. For the part A, the concentration is much lower than the Km, and for this one here, they gave it 0.125 nanomolar per minute. But anyhow, you calculate that, and we know the formula, and that's one of the formulas, the three formulas only that you need for this exam. Question number 7 talks about a figure, and it gives a curve there, and different versions. This one here asks you to draw what would be for low affinity bind. Then if low affinity, you put it below the curve that's there. And there's another version that's called for a high affinity, so that you put it above that line there. Question number 8 is about a pheromone binding protein in equilibrium to form B and A in this order, and it gives the equilibrium constant and the different numbers for different versions of the exam. This one here is 2 10 to the power of 2, so 200 at pH 4.5 and the 20 Celsius. And they ask you what's the predominant species. Okay, if the equilibrium is larger than 1, the species on the right side is the predominant species. That was a very easy question. A is the predominant species here. And in part B of this question, I ask you to calculate the free energy of Gibbs. And the delta G naught is equals minus RT log, natural log of KQ. You have KQ, have T that you have to transform that into absolute temperature by adding 273, and then you have R that was given in the exam. So just plug in these numbers. If you make some mistake, you forgot the sign, that's a very significant mistake, but even so, we are going to give you partial credit for that. So there's not all or nothing here, there are partial credit. That's why it takes time, because we have to read one by one very carefully, okay? So question number 9, it was about the Viagra as an inhibitor of PDE5. And they ask you what's the best graphic for that. And we know that Viagra is a competitive inhibitor, right? So that it resembles the mimics the transition state or the substrate, and it gets competed with the substrate for the binding pocket. We know that the higher concentration of the substrate can outcompete the inhibitor. Therefore, the maximum velocity is not going to change. However, the Km change, and we explained this thing multiple times, that the measurements give the impression that the affinity has decreased, right? And then the Km is going to increase. So we are going to get Km that's going to be increasing, and the maximum velocity that's unchanged, that's a competitive inhibitor. So we're going to read everything that you said, even if you didn't say right. I'm going to look at everything to make sure that we give a fair grading as much as possible. Question number 10, the last one, was about Bruce Hammock work, and they asked you which enzyme was targeted by the inhibitor that helped save the life of a horse named Hula Hula. So this is obviously soluble epoxide hydrolase. Uh, you could have written SEH, or you could spelled out, or you may even give something wrong about it. We will look at the site to see if you had any information there that's valuable, and give you partial credit for that. So that's all. I thought that by giving you this information, lower a little bit the anxiety. From the small sample that we have so far, we see that the class did great in this exam. The mean is going to be very high. Many students did much better in this exam than they did in the midterm too. And as a consequence of that, the grade from midterm 2 is going to be replaced with this one, but we cannot say how many because it's just a small sample so far. So we are going to continue this work and hopefully, like I said, complete that today or tomorrow, submit it to the registrar office, and once that thing is done, with the email, I'll send you an announcement and I'll show the breakdown of how many A plus, how many A, how many A minus, and so forth we have in the class. All right, so hang in there, keep doing a good job with the other final exams, and they have a great time during the break. It was a pleasure having you in class, and I wish you the best.